All right, we are going to work on writing a scientific hypothesis. This is going to go with the independent, dependent, and control variable sort that we just finished. When following the scientific method, forming a hypothesis takes place after asking a testable question and conducting research. A hypothesis is an educated guess or prediction about the outcome of an experiment. A hypothesis must be testable and contain an independent and dependent variable. For science, most hypotheses are written as if, then, because statements. Example: if compost is added to tomato plants, then the plant will grow more tomatoes because the plant will have more nutrients to make tomatoes. All right, so what is the independent variable? What are we purposely changing? That would be the amount of compost. What do we want to measure then is going to be the number of tomatoes. So this is our if. This is our independent variable, and this is our dependent variable. Notice that the if portion of the statement is followed by an action or change or procedure. This is the independent variable and the cause of the predicted change. The then portion of the statement is the dependent variable and what the scientist would measure or the effect. The because is also an important part of the statement because it is based on observation, research, or previous knowledge about the topic. It explains what you think is the why. So the if is going to be our independent variable, the then is going to be our dependent variable, and the because is going to be our why. So when we're writing a hypothesis, you need to choose a side. What I mean by that would be if you are going to put a plant in the sunlight. So sunlight, yes. Or our other option would be sunlight, no. All right, so writing your hypothesis, you're going to have to choose whether you're going to write your hypothesis based on yes, the plant in the sun and what do you think is going to happen, or you have to pick no for the sun and what you think is going to happen. Okay, all right, so the first question is, how does the amount of water affect the height a sunflower grows? So what we are purposely changing is the amount of water. So that's our independent variable. What we are measuring is the height of the sunflower. That is our dependent variable. So our independent variable is the if. So we need to think, what do we want to do with the water? Do we want to have, no water? Or we want to have normal amount of water? Or do we want to have like overwatering? So I'm good. That would all be decided during your setting up your experiment or thinking about your experiment, what you would like to do. So I'm going to choose the no water. Let's try that. Okay, so if no water is added to the sunflowers, and I apologize, my stylus is at school. So if we don't have water, so if no water is added to the sunflower, then, so now we need to comment on the height of the sunflower. Okay, so then the height will be less. And then we need to think about the why, because flowers need water to grow. Now we also could have talked about if 1 liter of water is added, or if 50 milliliters of water is added, and what do we think is going to happen to that sunflower? Okay, so here is our second scenario from that sort. How does the amount of fertilizer affect how many potatoes a plant produces? All right, so what are we purposely changing would be the amount of fertilizer. What are we going to measure? The number of potatoes that are produced. So if, let's say in with our experiment, we were thinking that we would have no fertilizer, and maybe we would add 100 grams of fertilizer, or maybe we would add 200 grams of fertilizer. So I'm going to just pick this one right here. So if 100 grams of fertilizer is added, then more potatoes will be produced. And now I have to talk about the why. Well, I know that fertilizer is like food for the soil. So by adding that food, we're adding nutrients because the fertilizer adds nutrients to the soil. Now I could have chosen if no fertilizer is added, then not as many potatoes will be produced because the soil will not have as many nutrients. So I chose a side. Okay, the last one. How does the mass of a paper airplane affect how far it will fly? All right, so what are we purposely changing? Is the mass of the airplane. What are we going to measure? Distance, how far it's going to fly. All right, so we would be running probably two different experiments here, one with an airplane with less mass and one with an airplane that had more mass. So let's choose less mass, okay? So we have two choices here, less or more mass, okay? So let's go ahead and choose this one. If the paper airplane has less mass, so then I need to think, and now I need to talk about how far it's going to fly. Do I think it's going to fly further? Or do I think it's going to fly less than my airplane that has more mass? So I would just pick a side. I would think, well, it's going to, then it will fly, no, I'm going to say farther. Remember, it is just an educated guess. So then why do I think an airplane with less mass is going to fly further? And because it will be lighter in the air. And it could be that I think that it won't crash because it's lighter, or maybe it's going to be more aerodynamic, or maybe I think that the airplane with more mass is going to fly further. And why do I think that? You know, maybe it's a little bit more stable, has a little bit more to it, is going to be floating through the air a little bit better, kind of like the idea of a real airplane. So whatever you think, you have to decide one or the other. Choose a side, and then what do you think is going to happen, and why do you think that's going to happen? Okay. All right, so this is just day one of looking at the idea of a hypothesis. We will have a lot more practice on this.